everybody. Today we're going to talk more about similar triangles. So you need to take out your packet and turn to page 7. If you want, you can pause the video and give these 2 warm-up questions a try, or you can do them along with me. The first one's a review. So it says the ratio of the angles of a pentagon is 2 to 3 to 4 to 5 to 6. Find the measure of the largest angle. So first of all, if it was a triangle, we would know all the angles would add up to 180. But with it being a pentagon, you first have to figure out what all the interior angles add up to. So a pentagon has 5 sides. So remember, you do 5 minus 2 times 180. All right. So just go to your calculator. We'll do 3 times 180. Oops. $540. All right. So all the angles in any pentagon add up to 540. Now, if you add these up, you don't get 540. But because they're in the ratio, that means they're all multiplied by the same thing. So we'll call it x. So we're just going to do 2x plus 3x plus 4x plus 5x plus 6x equals 540. All right, so we'll add those all up. So we have 5 and 10, and then another 10 would be 20x equals 540. To get x by itself, we can divide both sides by 20. If you don't know what it is, go to your calculator. That's what it's there for. 540 divided by 20. 27. Okay, now, if this were a multiple choice question on the test, that would be the first answer choice, or on the regions. But it wouldn't be correct because, again, you want to make sure you answer the question. They're looking for the largest angle, which would be your 6x. So now we're just going to take 6 times 27. We'll throw it into the calculator. We already got the 27 in there, so just hit times 6. And there you go, 162. And it is an angle, so it's degrees. All right. The next one we'll do more work with today, but it says determine if the rectangles are similar. Explain. If they're similar, then write a similarity statement. Well, first of all, with it being a rectangle, 5 corresponds with 3, and 8 would correspond with 4.8. So we're going to set up a proportion and see if the fractions simplify to the same thing. So we'll do 5 over 3. Since I did the bigger rectangle to the smaller, I'm going to do the bigger rectangle to the smaller for the second fraction as well. All right, so 5 over 3, we can't simplify that. All right, 5 divided by 3, got a decimal, math, enter, enter. Talked about this yesterday, 5/3. Do the same with 8 divided by 4.8. Math, enter, enter. 5/3 as well. So that means the sides are proportional, which means yes, they're similar. All right, 5/3 is your similarity ratio. And we want to write a similarity statement. So we're just going to say rectangle JKLM. Remember, when you're naming it, you don't want to pick up your pencil. You want to go right in order. JKLM would correspond with PQRS. So it's similar to PQRS. Remember, similar means same shape, just a different size. All right, so let's do a little bit more with it today. Showing or proving the triangles are similar. It's kind of like what we did with triangle proofs with side angle side, 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 side. There's only 3 ways to show similarity. The first one is showing that 2 of the angles are the same, because if 2 of the angles are the same, the third will be as well. So maybe you know this angle and this angle are the same, and this angle and this angle are the same. So if you have 2 triangles where you know at least 2 of the angles are the same, you can say that they're similar. The second way is to show all three sides are similar. And by similar, it doesn't necessarily mean they're the same size. They simplify to give you the same ratio. All right, so side, 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 or side, angle, side, where two of the sides give you the same ratio and the angle in between them, or the included angle, is the same. Couple things to remember. Sides are proportional, not congruent, like I just said up here. These are clearly not the same size, but they are similar because they're all simplified to the same ratio. Some review, remember your reflexive property. If I say, angle A is congruent to itself. If something's congruent to itself. Vertical angles, remember, are formed by intersecting lines and they're congruent. Perpendicular lines form right angles and those are congruent. Also something to think about when you have parallel lines cut by a transversal, you've got alternate exterior, alternate interior, corresponding, same side interior. All those will come up a little bit in the next few days. Okay, so let's look at an example. Explain why the triangles are similar and write a similarity statement. So again, it can be by side, angle, side, 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 or angle, angle. I don't see any mention of sides here. I do see angles, so we'll try for angle, angle. Right now, they're not the same, but right here we have a right angle and a right angle, so there's one of our angles. Now, if you know two of the angles in a triangle, you can subtract from 180. So we have 90 and 43, that's 133. If we subtract from 180, we get 47 degrees, which matches this. If I subtract from 180 over here, I get the same. So because the angle measures are the same, they are similar by angle, angle similarity. So two angles are similar to two angles in the other. And write a similarity statement. So I tend to go alphabetical. So triangle ABC is similar to, remember, not the same size, similar to triangle. Now, make sure you label this one right. Since I started with 43, 43 would be this one over here. So triangle D, B was our right angle, so E is our right angle. That's next. And F. So they're similar by angle, angle similarity, and there's your similarity statement. All right, let's do another one that's similar. It says verify that they're similar. All right, so it tells us what things match up. Right now I see two sides on each. So it's not angle, angle. It's not side, 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 because we don't have the third side. What we're going for is side, angle, side. And if you notice, side, angle, side, it would have to be this angle is congruent to this angle. We can always say that. Angle 1 is congruent to angle 2. What type of angles are they? Formed by intersecting lines, vertical. So now we just need to check to see that our sides are proportional. So we got to make sure that they simplify to the same thing. So let's start with 12. That's side TX. So if you look up here at your similarity statement, TX corresponds with VX. So 12 corresponds with 16. And we want to see if that simplifies to the same thing as, since I started with 12, I got to start with 15 over 20. And again, if you look, 15 is side UX, the last two letters, so it corresponds with XW, which is 20. All right, so let's simplify those and see if we get the same thing. Another thing you could do is cross multiply. If you get the same product, it's the same, but all right, 12 divided by 16. Math, enter, enter. 3/4. All right, now we're going to do 15 divided by 20. Simplify it, math, enter, enter. 3/4 as well. So, because those are congruent, the sides are proportional, the angles in between them are congruent. So yes, those two triangles are similar by side angle side being similar to side angle side. So a little bit of a proof here. And again, the 3/4 is called your similarity ratio. All right. Verify the triangles are similar. Find the value of x. All right. So these are actually similar by angle-angle similarity. All right, because we've got vertical angles. So kind of an informal proof here. And then these are parallel. So I talked to you about this a few minutes ago. Think about two parallel lines. If you have angle F and angle J, those are congruent because they are alternate interior, same as E and H. So I'm just going to say that angle E is congruent to angle H. Oops, I should probably write E. There we go. And angle F is congruent to angle J because they're alternate interior. And when you have alternate interior angles and parallel lines, they're congruent when the lines are parallel. So it is congruent by angle-angle similarity. Now, if we want to find x, we want to set up our proportion. It's going to be very similar to what we did here. Remember, 12 matched 16? Same thing here. 2x minus 2 is going to match 15. And then for my second half of the fraction, I started up here, so I want to do x plus 9 is corresponding with 20. All right, so now you can just cross multiply. 20 times 2x would be 40x, and 20 times negative 2 is negative 40. Over here we have 15 times x, which is 15x, and 15 times 9 would be 135. Let's just double check. Yes, even math teachers like to double check themselves. Okay. All right, if you have trouble solving equations, don't forget, stop by and see me. Sometimes it's just practicing a couple together. All right, so we got to combine the x's. They're on different sides, so I'm going to bring that 15x over. Since it's positive, we'll subtract it. So we have 25x minus 40 equals 135. We'll add 40 to both sides. So 25x equals 175. And then we'll divide by 25. And we should get 7. Again, if you're not sure, 175 divided by 25. If you have $1.75, how many quarters you got? 7. And it said find the value of x. There it is. All right. Last couple, we're dealing with overlapping triangles. So again, we're going to explain why they're similar. And you might not see it, but it tells us angle T and angle S. All right. But both triangles share angle R. So angle R is congruent to itself. And we know that by the reflexive property. But for me, sometimes it helps if you pull the two pictures apart. This will be especially helpful on a couple of your homework questions, which if you don't get, that's okay. We're going to practice them together. So we got the smaller triangle, and then we got the larger triangle. And again, those are the same, and those are the same. Use different markings. So they're similar by angle-angle similarity. All right. So now we have, I'm going to just label my side. So RTU, we have 12. RS is 10. SV is 8. It wants us to find RT. So in the picture, it's this whole side. But if you pull it apart like I did, it's easier to see what matches. So x matches 10. And since I started with this bigger triangle, 12 matches 8. So x over 10 equals 12 over 8, and now you can just cross multiply. 8x equals 120. Divide by 8. 120 divided by 8. 15. So RT equals 15. All right, and we'll practice with questions like that over the next couple of days. Okay, explain why the triangles are similar and find AC. Once again, we've got these two matching angles, and they have a shared angle at E. So they're similar by angle similarity. All right, let's pull them apart and look at our picture. So let's do the big triangle first. We have A, B, E. Gave us 14. And then we have C, D, E. It gave us 10 and 8. It wants us to find, it just wants us to find this little section right here. Well, you've got a couple options. You could find this whole side right here, AE, and once you have that, you can just subtract the 8. So why don't we do it that way? Because now that I have these pulled apart, I can say, okay, 14 over 10 equals x over 8. Cross multiply. 10x equals 14 times 8. 112. Divide by 10. X equals 11.2. Okay. So if this whole thing is 11.2 and you just want to find this section, take 11.2 minus 8. So 3.2 would be the length of AC. All right. There is one other way that you could go about that question. You could have said 14 over 10 equals, you could call this y plus 8 over 8, and you'd end up with 3.2 right at the end. But I personally have found that it's easier if you just pull them apart. We'll look at an example. Let me see which one it is. This one here on the next page, the one at the bottom. Give that one a try. That one's a little bit tricky. What I would suggest is you call SPX, and then this whole thing would be 6 plus x. But again, we'll practice with that. So your homework, it's going to be the same on 23 as well. But do your best on these. Your homework is pages 10 and 11. And I will be back tomorrow so I can help you with any of these. If you have questions in the meantime, don't forget to stop by the Math Lab. Have a great day, guys.